Okay, as we talked about today in class, we're looking at quadratic functions that are have a graph that looks like a parabola, and so this would be an equation of y is equal to ax squared plus bx plus c. And as we talked about, our axis of symmetry is the line that you can fold the parabola in half, and it's equal distance from the axis of symmetry to the outside line of the parabola. Our zeros are the point at which it crosses our x-axis. We have a y-intercept, and then our vertex is either the lowest or highest point on the graph. And don't forget, we can tell that by whether it's going to have a maximum or minimum point based on looking at the equation. So for instance, our equation here has a positive ax squared, so therefore our vertex is going to be the minimum point because it's going to open upward. And in this equation, we have a negative ax squared, and so our vertex is a maximum point because the parabola is going to open down. Remember what I've said, if it's positive, then it's a smile, and if it's negative, then it's a frown. The equation to find the axis of symmetry is that x is equal to a negative b over 2a when our equation of y is equal to ax squared plus bx plus c. And remember, when we are talking about linear equations, any equation that is x is equal to and then a certain number is going to be a vertical line because it is an undefined slope. So therefore it's not going to cross our x-axis. So if we say that this would be our axis of symmetry, for example, then when we have an x is equal to line, same equation of the line. The definition of roots are the solutions of a quadratic equation, but in other words, it's the x-intercepts, or it can also be called the zeros. So for example, if we have a quadratic equation or graph, our two zeros here and here are going to be, you could call them either the solutions of the equation, the x-intercepts of the equation, or the zeros. Three different terminology, words, definitions, but they all mean the same thing. Depending on how the graph looks, a quadratic function can have two roots, in which case it's going to look like this because it crosses the x-axis in two locations. It can have one root where it'll look like this, where you can see it only hits the x-axis in one location. Or it can look like this, where it's not going to cross or hit the x-axis at all. So for example, if we have a quadratic function that has two roots, we're going to see that it crosses at the x-axis at two places, which we can see when we factor, because we're going to get two factors of x plus 7 and x minus 1. And if we set those equal to 0, we have that x is equal to negative 7, and then x is equal to 1. We also see that our y-intercept is going to be negative 7, and so we can sketch the graph showing the two roots. Similarly, if we have one root, which is also called a double root, and we factor, we're going to find that, for instance, in this scenario of x squared plus 4x plus 4, it will factor into x plus 2 and x plus 2. While solving for both, we're going to find that x is equal to negative 2, and when we do it again for the other root, it's x is equal to negative 2. So therefore, our point's just going to kind of touch the x-axis. We also see our y-intercept is 4, and so we can say that our graph is going to look similar to that. And finally, if there's no real roots, we find that the equation basically is not factorable. Doesn't mean we can't solve it, which we'll talk about in a day or two. But if you think about, we need to find the factors of 4 that equal a negative 1. Well, the factors of 4 are 1 and 4 and 2 and 2. None of those are going to end up giving us a sum of a negative x. So it doesn't cross the or x-axis. The graph is actually going to look similar to this. And we'll talk about in a day or two how to go about solving and graphing, because it is possible, just not by factoring. There is a formula called the discriminant that will tell us whether or not a quadratic has no real roots and one real root, or the double root, or 2 roots. And this can help us so that before we start looking for factors of an equation, it'll tell us whether or not the equation or quadratic function is actually factorable. So for instance, if I have the equation of y is equal to 2x squared plus x plus 3, I know that a is going to equal 2, b equals 1, and c equals 3. When I put it into my discriminant equation, that means I'm going to have 1 squared minus 4 times 2 times 3. When I simplify that, I get 1 minus, 4 and 2 is 8, 8 times 3 is 24, which gives me a negative 23. Since my number is negative, it doesn't matter what the number is, it's just that it's negative. That means that there are no roots. And since there's no roots, it's not factorable. Okay, let's take a look at the equation x squared plus 6x plus 9. Okay, well that means that my a is equal to 1, b is equal to 6, and c is equal to 9. When I put that into my formula for the discriminant, I find 6 squared minus 4 times 1 times 9. Well, when I simplify it, I get 36 minus 36. Well, that equals 0. If your discriminant number is 0, then that means that there is one root or a double root, and therefore it's going to be factorable. And finally, if we look at the equation of x squared minus 5x plus 2, that means that my a equals 1, b is equal to 5, and c is equal to 2. When I put it into my discriminant of b squared minus 4ac, that means I'm going to get 25 squared minus 4 times 1 times 2, which is going to give me 25 minus 8, which is a positive 17. Again, doesn't matter what the number is, just the fact that the number is positive, and that means that there are 2 distinct roots, and again, this is factorable. There's a table in your book, and I'm actually going to give you a foldable to put into your notebook tomorrow of this table that goes over and is a reminder of how the graph is going to look depending on the discriminant and what it tells you about whether it's factorable. And that is on page 549 in the book. Okay, but bottom line, discriminant is very useful when we're graphing a quadratic function because it lets us know first off whether it's factorable, which method we want to use to go about solving it, and overall what the graph is going to kind of look like.